The most important concept, microservices, right? So we have already seen the history of distributed systems from monolithic to SOA and then to microservices architecture, right? So it's an architectural style that structures an application as a collection of two or more services that are independently deployable and loosely coupled. Loosely coupled means there is no dependency between the microservices, right? Microservice is a small loosely coupled service that is designed to perform a specific business function in which each service can be deployed, developed and scaled independently. Anytime I want to increase the scalability, deploy it, make a change, develop a new microservice, it is independent of all the services, right? Services are typically organized around business capabilities. Okay, so each service will do one task. Microservice follows single responsibility principle, SRP, means each service should perform a single task. Another important advantage of microservices is it can be written in variety of programming languages and frameworks, and each service acts as a mini application on its own. Each one could be a mini application, right? We can write each microservice in any program. You can write microservice in any language, one in Java, one in Python, both can talk to each other using REST protocol, REST communication, right? They are least bothered about the implementation details of each of them. I will send a request, I should get the response, that's it. It could be in any language, right? So some characteristics of microservices: small and focused services, they should be very small. Decentralized data management. So if I should not have one database and all microservice hitting this database only, again it becomes tight coupling with the database. If this database is down, nobody can access the application, right? So there should be, the data should be neatly decomposed. We should have decentralized data. It means each microservice should have its own database, right? Independence is the characteristics. I should develop them independently, I should deploy them, test them, everything I can do independently without impacting the other services. Technology heterogeneity, you can write using any technology, right? Scalability is another thing, because we are deploying them in cloud, they become scalable, and scaling only the payment service is easy instead of scaling the whole application, right? Fault isolation, one microservice failure does not impact the other microservice failure because they are independent in each other, right? And improved maintenance downtime is very low. To make among those 20,000 microservices, I have to change only one or two microservices, which is very easy task, right? So these are a few important characteristics of microservices. Okay, so some success stories of microservice. Netflix was the first one to adopt these microservices. It has 500 plus microservices and API gateways that handle over 2 billion API edge requests every day, right? Netflix engineers deploy code thousands of times per day. So many thousands of times per day they deploy because there are so many microservices. Today, Netflix services 93.8 million users globally. So it's able to handle that. It's only because of microservices. Next, the Amazon website, what we see, right? The Amazon provides infrastructure for microservice to AWS, and Amazon engineers deploy code every 11.7 seconds. It means that frequently they do it. Spotify has 810 services. Spotify app, what you use. So there are so many companies who are, or the products who are using microservices are as their architecture. See this diagram. This is released by Amazon, right? Probably in 2020, I think they have released this diagram, Amazon Death Star. Today, the Amazon shopping website, what you are seeing, has 23,000 plus microservices. So each dot here, right? Each one is a microservice. In this diagram, each dot is a microservice, right? So you see how complex it is. Such a huge number of microservices in Amazon. Same way for Uber. See here, we have very small dots, right? Each one is a microservice. Each one is a microservice. There are n number of thousands of microservices even in Uber, right? So what are the key technologies for designing microservice? What should I know to design a microservice? First one is container, right? Then Docker and Kubernetes. What is container? a unit that runs one microservice. So container is basically a box in which I can put one microservice and all its related configuration, everything I will dump into a single box, a container, right? And this I will be using for deploying and shifting it from one platform to the other. What is Docker? Docker is a software, it's a tool which is used to create containers. So when you are writing microservice code, right, you write the microservice code in Java. Using this code, you will be using Docker to generate a container, right? This container contains the whole microservice and its dependency files. So Docker is helping us in creating these boxes. And Kubernetes, it's a system to manage many containers. So from Kubernetes tool, we can manage the containers. We can see all those 1000, 2000 or 10,000 microservices, that is 10,000 containers, because each microservice will be deployed in a single container. So one container, one microservice. So there will be lot of containers. So the container management is done using this Kubernetes software, right? Let's understand in detail. What is a container? Container is a standard unit of software that packages an application and all its dependencies like code, runtime, system tools, library and settings. What all settings you want to do, the runtime, system tools, the libraries, everything you are packing it in a single box, single container. Container is a lightweight package that contains an application plus everything it needs to run, like the code, libraries, configuration, runtime, everything. In microservices, each microservice runs in its own container. So for one microservice, one container will be there, right? Container ensure that an application runs consistently regardless of the environment. So when we are having different environments, no, in real time if you go, we have SIT environment, you have UAT environment, then we have prod environment. Okay, so SIT means testing environment. This is user acceptance testing. So then we have dev environment. So developers will be actually writing the code in this environment. Then they will shift it to SIT and give it to tester. So when the testing team completes the testing part, then they will give it to user to test it in another environment. Once user says okay, then we deploy that in production environment. So when I am shifting that code from one environment to other environment, I have to manually change so many settings. To avoid that headache, we are putting them in the container. That's why it says that ensures that the application runs consistently regardless of the environment. Because developers always say, but it works only in my machine. They will say it is working in my machine, I don't know why it is not working there. Because there are a lot of configuration settings required. To avoid that problem, we are dumping everything into a container and we can easily move container from one environment to the other environment so that it works happily. Right? That is called a container. Next, Docker. Docker is a software. It is used for creating containers. It's an open source platform used to create containers. Right? So it does some task. What it will do, it will create images and it will help in running the containers. So developer use a simple text file called Docker file to create the Docker image, which is a read-only template for a container. So we will actually use a file Docker file and create a Docker image. This Docker image is actually put into the container. Okay, then running those containers. Docker engine is a runtime environment that run instances of these images as isolated containers. So Docker engine helps in running those containers, right? So in simple terms, if you see, package microservice into an image, Docker helps us in packing the microservice into an image format, right? Then run it as a container. That image we are running it as converting it as a container, and then pushing that container into the registry. Pull and run it anywhere, whichever platform you want, you can pull that container and run that particular microservice, right? So that code is converted to an image file. That image is being converted to a container. This container I am throwing it in a repository. Wherever you want, in dev you want, you run in dev. In testing SIT environment you want, you run it there. You want in UAT environment, you run it there. Wherever you want, you can run the container, right? So this is the purpose of Docker. And the last one, Kubernetes. Kubernetes is used for managing those containers, right? So it typically uses containers created by the Docker, right? So Kubernetes is a system that manages many containers automatically. right? So Kubernetes is an open source container orchestration platform that automates the deployment, scaling and management of containerized applications which are put in the containers, especially in large scale production environments, right? So these three are the important technology or tools which you have to learn if you want to design microservices and deploy them, right? Container, Docker and Kubernetes. Okay, so this is all about the microservices or microservices architecture. Thank you.